Alright, so yes, today we started talking about systems in class, and remember we defined a system as two or more lines. Alright, that was our definition of systems that we gave. And when we solve our systems, as you see here, we have two equations, which means we got two lines. Our goal is to find an intersection point. Our goal is to figure out if there's an intersection point. So if we just look at our two examples here, our first two examples, we've got three solution possibilities over here. Our goal is to determine which one of these three, if it's an intersection point, that means it has to be a part of this equation and it has to be a part of this equation. So our goal is to determine which of these 3 points works in both of them. Okay, so for example, 3 times 4 plus negative 2, plug that in there, 12 plus negative 2, we definitely get a 10. So that works for the first equation, but if we come down here, substitute in our values, 4 minus 2 is definitely not negative 2. So that one's wiped out. Then we can come to the next one, we can try 3 and 1. 3 times 3 is 9, plus 1 makes 10. Check. Substitution. 3 minus 2 equals 1. Check. That's our intersection point because it works in both of our equations. Okay, so sometimes we can just, evaluate, give some points for you to choose. A second way to deal with systems is to just give you two equations by themselves and ask you to calculate the intersection point. Alright, so that's our goal, to figure out, do these two equations have anything in common? We have no place to start because unlike up here we were given some points, now we have no points. So if we have no points, then we got to come up with our own for both. For both. So a lot of guessing and checking here. 0 minus 0, that's going to work. 4 and 2 have the number 8 in common. So if we would do 8 minus 8, that's going to give us 0, so 2, 4. Again, once we get to a couple of points, now we can just use patterns. Plus 2, plus 2, plus 4, plus 4. And again, if you would check that, that would be 16 minus 16. Over here we have a fraction. Definitely want to try 0. 1/2 times 0 is 0 plus 5. That will get us up to 5. So 0 and 5 go together. Remember, anytime fractions are involved, the denominator is your clue here. Our numbers that are going to go together are your 2's. Those are going to work the best here. So 1/2 of 4, that would be 2. And so we're going to need to add on 3 more to get up to 5. 1/2 of 6 is 3. So we're going to need to add 2 more. Okay. So now we got some points. Now if we look, sometimes we get lucky, kind of like up here, we'll find a matching set. And here though, if we look back and forth, none of these are exactly the same, so we have not found a solution yet. However, we have more options. Remember, once we get these 3, now we can graph. So if we can graph here, we need a dot at 0, 0, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. So we can create a graph. And there's our first line. And if we graph our second line, 0, 5, 1, 2, 3, 4, 1, 2, 3, 5, 6. If we draw the second line, we should notice, hey, they got something in common. We have an intersection point right there. 1, 2, 1, 2, 3, 4. So their common goal, their common intersection point, is 2, 4. So that's your goal for tonight. As you do your homework, looking for those intersection points. As always, do the best you can, and we'll answer any questions you have in class tomorrow. Have a good night.